Okay, so we're going to find the least common denominator of 3x over x minus 3 and 4 over x plus 4. Yes, Bert?
Don't we get tomorrow to work on the homework from yesterday and today? Isn't that what you said?
Yes, tomorrow's work day. Okay. So, I want to find the least common denominator. Least common denominator requires knowing the factors of the denominators. Can I factor x minus 3? No. If I cannot factor it, but it has pluses or minuses, what should I do with it? Put it in parentheses. Even if you don't physically write them, you at least need to recognize that they're there. How about x plus 4? Can I factor that? No. Now, one of the things we talked about yesterday is that the least common denominator takes one of everything that the denominators have in common and then takes everything they don't have in common. And I'm talking about the full factors. So, my factors in my denominator are an x minus 3 and an x plus 4. You do not pull the x out of the parentheses. Do they have anything in common? No. Which means my least common denominator is just made up of the things that they didn't have in common, which in this case is just both denominators. Sometimes they will not have something in common. Five over x cubed minus 9x and 2x cubed minus 6x squared. First off, can I factor the denominators? First one, what am I doing? Taking an x off. Leaves me with x squared minus 9. Now, I'd be doing this off to the side if I was doing more than just finding the LCD. Okay, can I factor that further? Yes. Difference of squares. What's that become? X plus 3x minus 3, and I still have the x from the GCF. So I'm no longer looking at that, I'm no longer looking at that, I'm looking at this as my denominator. 2x cubed minus 6x squared. Can I factor it? Greatest common factor? 2x squared, leaving me with x minus 3. Do my denominators have something in common? They have an x minus 3 in common. Now, in all technicality, they do actually have a little bit more in common than that. The monomials. X, 2x squared. But when it comes to the monomial piece, I don't look so closely at what they have in common. More so, I look at the monomials and I imagine, what if those were the denominators? What would be our least common denominator at that point? So, I look at the binomials they have in common and I look at the monomials separately. X and 2x squared. If those were purely my denominator, what would be the least common denominator? Start with numbers. What number is hiding in front of that x? 1. What's the smallest thing both 1 and 2 can become? What's their common multiple? Not their common factor, their common multiple. 2. I can change a 1 into a 2. 2 already is a 2. So, 2. I start with those. And now I've got x and x squared. What's the smallest thing they can become? What's their smallest common multiple? X to the power of 2. With monomials, remember, it's variable to its smallest power. Now that takes care of the monomials. The monomials I kind of do as the separate thing. Now I go back to my binomials. I need one of every item they have in common. What do they got in common? What was it again? The x minus 3. So I need an x minus 3 in here, but I only need one of them. Is there anything that we haven't taken into account? X plus 3. Now, while we're at it, we didn't do it on the first one, which isn't the end of the world. What would I need to multiply the first fraction by to get it to be the common denominator? Break it down into pieces. Look at the monomials first. How do I change an x to make it a 2x squared? Multiply by 2x. So that's that part. Now look at the binomials. This has an x plus 3. This has an x plus 3. Do I need any more x plus 3s? X minus 3, x minus 3. Do I need any more of those? Is there anything else over here that I don't have? No. Okay. The second fraction. Monomials. I have 2x squared. I want 2x squared. That's good. I have x minus 3. What don't I have? An x plus 3. Technically, in parentheses is what I want. It's going to be an important piece. We're going to do one more LCD and then we're going to get to some actual adding and subtracting. Find the least common denominator. What do I have to start with again? Factoring the denominators. Start with GCF. 9x squared minus 72x minus 180. Each of those divide by 9. X squared minus 8x minus 20. Can I factor that further? Full AC, or can I do the shortcut? Shortcut, two things that multiply to negative 20, but when I add them, I get negative 8. Negative 10, positive 2. Since it's the shortcut, I go directly to my parentheses. Again, in the actual problems, I would do my factoring off to the side. Okay, second one, GCF. 6 x squared plus 7x plus 10. Shortcut, two things that multiply to 10 but add to 7. 5 and 2. Find my least common denominator. Work with it in pieces. You can start by looking for what they have in common. I most commonly actually look at the monomials first. The monomials are that GCF that you factored out, the things without the pluses and minuses. 9, 6. Least common multiple of 9 and 6. 18. 18. Least common multiple, not greatest common factor. It's what they can multiply into, not what divides out of them. That is a very common thing that people go back and forth with. Okay, 18. Now, I look at the actual binomials. Do they have anything in common? If they have something in common, how many times do I need it to show up in the LCD? Once. Unless, of course, there's an additional x plus 2 somewhere. Is there? No. What else does my LCD need, though? X minus 10. X plus 5. Does it need a 6? No, that was taken care of by the 18. Does it need a 9? No, that was taken care of by the 18. What would I have to multiply the first fraction by to get the LCD? Yep, 2 and an x plus 5. Second fraction? 3 and the x minus 10. I don't need all of these open. Okay. You will notice that my instructions throughout this section, throughout this trimester so far, have generally been simplify. I do not separate add, subtract, multiply, divide in instructions. They are all a form of simplify. N squared over n minus 3 minus 9 over n minus 3. When you are adding or subtracting, first thing you need, common denominator. That's kind of them. Once you have a common denominator, how do we subtract again? Straight across both top and bottom? Just the top. What do I do with the bottom? In other words, keep it the same. After I subtract, I combine like terms if possible. Is it possible? No. But now I need to simplify the fraction. Do not forget, you have to simplify the fraction afterwards. If I want to simplify these, what do I do? Factor. Top, bottom, or both? Not the bottom? Technically you would try, but you can't. Okay. It is a one-step factoring, so I'll leave it in the fraction form. What does n squared minus 9 factor to? Beautiful. Canceling out. N minus 3. Final answer is n plus 3. So far, not too bad. I always start at least one with a common denominator before I make it go crazy. subtracting. I need a common denominator. I don't have that. To find the common denominator, I start by factoring. Top, bottom, or both. Bottom of the fraction. When adding and subtracting, you do not want to factor the top. Eventually we'll have to simplify and we will have to factor it, but you do not want to do that until it's down to one fraction. So, as I mentioned before, generally on these ones, I will pull the factoring off to the side. Or in this case, I guess I'm going downwards. Greatest common factor of that first one. 10x, leaving me with x squared minus x minus 6. Isn't it? Can I factor it further? Can at least try. Are there two things that multiply to -6 but add to a -1? -3 positive 2, and since it's a shortcut, x minus 3, x plus 2. Can I factor it further? No. 5x plus 10. 5, x plus 2. Least common denominator. Must work in pieces. Look at the monomials first. I got 10x and I got 5. If those were the denominators alone, what would be the LCD? LCD is not a factor. It's not what you divide out. It's what they can multiply to become. They can both become 10s. Kind of. X. There we go. In common, they have an x plus 2. I need one of those. I also need an x minus 3. So, I am currently looking at x minus 1 over 10x, x minus 3, x plus 2. And I am subtracting 4 over 5, x plus 2. Now, some people at this point just choose to write the factored form up here, or they mentally skip to it. I'm okay with that. I'm gonna rewrite what we got. What am I missing out of the first denominator to make it the LCD? Got that, got that, got that. I'm not missing anything. 1? Do I really need to multiply by 1? No. Okay. Second fraction. What's it missing?
5x.
Not quite. 2x. And the x minus 3. Now, when we multiply these things, we do have to remember some things. Things are already grouped together. For example, there are parentheses right there. Now, with a 1, does it really make a difference to multiply by 1? No. But if this was anything other than 1, I would need to distribute. The first fraction, this time around, is not changing. The second fraction, I've actually got to do some work to make this a thing. I do have the parentheses here. What is getting distributed into those parentheses? Technically not just 2x. All of this is getting multiplied, which means these two things together are getting distributed in. What is 4 times 2x? 8x. That is what is getting distributed into the x minus 3. And you do want to distribute numerators. Until it is a single fraction, you want it multiplied out. The denominator you don't want to multiply out, because the denominator is not changing from here until the end of the problem, until we start crossing things out. So the denominator you leave in factored form, but the numerator you do want to multiply. 8x times x, 8x squared. 8x times negative 3, negative 24x. The denominator, you're going to leave in its factored form, but its factored form does include the monomials multiplied together. The 5 times the 2x I am going to turn into 10x. But the rest of it, I'm just going to leave with the x plus 2 and the x minus 3. Do I have a common denominator finally? Sweet. Once you have a common denominator, now you can do the addition and subtraction. When I subtract, one of the things we talked about yesterday is I have to be careful of those groupings again. Technically, this is grouped. Does the first one being in parentheses make a difference? Technically, this is grouped. Does the second one being in parentheses make a difference? When you're subtracting and it's got pluses and minuses, it does make a difference. Because right now what I have is I have x minus 1 minus, and then in parentheses, 8x squared minus 24x. Now, I do not care if you write this step out or go directly to distributing that negative. But do not forget to distribute the negative when you're subtracting and it's a binomial. Like I just did. At this point, we are not done with the problem. You subtract, distribute the negative, now that's positive, combine like terms, and then we can see if we can simplify. Now, when you combine like terms, I highly recommend you put it in standard form. Meaning, biggest exponents first and decrease from there. Because standard form is easier to factor if something factors. looks fantastic, doesn't it? And by looks fantastic, I mean this is pretty dang ugly. I am well aware of that. We would still try to factor. We would still try to simplify. Technically, this one does have a greatest common factor. Traditionally, when you're factoring, you do not want to leave the first term, when it's in standard form, negative. I don't care if you factor out the negative or not, just know that you can. You can skip that step, but it just might lead you to some negative or some opposites later. Shortcut, or do I have to do the full AC? Full AC. First thing I do is negative 8 times negative 1, which is 8. Are there going to be two things that multiply to 8, but when I add them I get 25? No, it's not going to factor, which means it's not going to simplify. This is the final answer. You have to be careful with that. Am I going to give you a lot that get this ugly in order to simplify?
Yeah.
A lot? Got it. Burton wants me to make the homework harder. Okay, I got one final example for y'all. Do we have a question?
Can we get like instructions, like a step by step, like what you do first, what you do next?
No.
Okay.
I don't give instructions on this on purpose because of the fact that when I give instructions on it, first off, people are more likely to mix up the instructions. And secondly, the instructions on how to do this are knowing how to do your adding of regular fractions. It's the same process, it's just uglier to look at. Okay. X plus 10 over 3x minus 15 minus 3x plus 15 over 6x minus 30. In order to add and subtract fractions, you need a common denominator. If you want to get a common denominator, you need the denominators factored. Greatest common factor of 3x minus 15 is 3, leaving me with x minus 5. Six x minus 30. Greatest common factor? 6. Leaving me with x minus 5. What is our least common denominator? 6 and an x minus 5. 3 and 6 can both in some way or another become a 6, and they have in common the x minus 5. What shall I multiply the first fraction by? 2? Yeah, that's all it's missing. What about the second fraction? Nothing. It's already got the LCD. It's kind of nice when it does that. When I get the least common denominator, because that's still the step we're on. In order to subtract fractions, we need a least common denominator. We're getting it. Make sure that you are distributing through the numerator. Do multiply through the top. Does the 2 multiply by the x, by the 10, or by both? Both, because this is grouped. 2x plus 20 over. Do I multiply through the denominator? No. Except for the monomials. Once you have the least common denominator, then you may subtract. Get the least common denominator. Then do the adding and subtracting. Is this correct? What did I screw up? Subtracting that. Gotta remember this is in parentheses, which means it's gonna end up being a negative 15. Now, a couple of you said combine like terms. You're not wrong, it wasn't so much a screw up, I just wasn't there yet. Negative x plus 5. Next thing I try to do is simplify. Can I factor the numerator? You can make an argument for yes, you can make an argument for no. Technically, we don't want to leave that first part negative. But if you don't factor that negative out, it's not the end of the world. You just have to recognize that that's technically in parentheses, and will it simplify? What do you notice about these two? They are perfect opposites. Positive negative x, positive negative 5. Opposites will cancel out, but they will leave you with what? A negative. Is my answer negative 6? No, it is negative 1/6. Let's remember the 6 is on the bottom. Okay. I knew today would be a little bit longer. There's our reason tomorrow is a work day. Your assignment, we are in the book, page 541, day 2. It is 26 through 33, 71 through 73. Got about 10 minutes today, so nothing crazy today. But tomorrow, I do have a skill builder for you, but otherwise it's work time.